My research group focuses on atomic mass spectrometry, and in particular our expertise lies in the field of inductively coupled plasma time-of-flight mass spectrometry. And that's abbreviated ICP TOF-MS. And what we mostly do with that technique is we measure individual inorganic particles from environmental samples. And what we're really trying to do is develop methods to characterize which particles in the environment are anthropogenic and which particles in the environment are natural, and figure out ways to distinguish between these two particle types so that as sort of a broader community of environmental scientists, we can get a handle on what is the footprint of nanopollution in the environment. This has implications for how particles interact in sort of the global environment, and has implications in important topics like climate and pollution and so forth. My group does a mix of both. So like I said, we're interested in measurement science, and so we take a lot of measurements in the lab, a lot of ICP-MS measurements. However, we do maybe not theoretical work, but a lot of work in data processing. So we do a lot of development of custom code in, say, LabVIEW or MATLAB or Python in order to analyze our data. And we also do fundamental studies of, for instance, what is the response function of a particular instrument? How can we understand that? And typically we use Monte Carlo simulations to try to understand how the different variables of an instrument contribute to its response, and if we can understand that, how we can apply that to our data analysis to get more robust and accurate measurements. My research group focuses on analytical chemistry. I'm in the analytical division here at Iowa State. However, we tend to think of ourselves more like measurement scientists. So most things that pertain to being able to take a good measurement, researchers in the group will attain those skills. So for instance, graduate students will get a detailed understanding of what ICP mass spectrometry is, how it works, how to take apart an instrument, how to put the instrument back together. They'll get skills in data acquisition, in data analysis. We do a lot of data treatment, develop our own code and things like that. Also, students will develop soft skills. I like to emphasize that students go to conferences and meet with other people and develop a way to have a scientific discourse with other researchers in the field, and also, of course, skills in terms of writing and reading scientific literature. Everyone in my research group has their own project, which they have agency to take in a direction that they see fit. But in addition, I meet with every graduate student once a week to talk about progress. Those can be really short update meetings that just are 5 to 10 minutes, or maybe the student comes to my office and they have a question and we get into a long discussion for an hour. But so it's guided research that we meet once a week, but every student has their own project which they can take in new directions as they see those possibilities emerge. Collaborations in my group are just getting off the ground. I've been at Iowa State for 2 years now, but we have established a bunch of collaborations with researchers here at Iowa State, as well as in the United States. So we have a collaboration with a group in Colorado, a collaboration with a group in West Virginia, with researchers in Brazil and Germany and Switzerland. So in my opinion, if the purpose of science is to develop a stronger scientific understanding of the problems that you're studying, the only way to do that is to bring in people with diverse expertise and diverse know-how, because that allows everyone involved to expand their knowledge. So collaborations are typically a win-win if you're really interested in expanding scientific knowledge. So that's why we pursue them. At Iowa State, we have a major research institution, so there are world-class scientists surrounding us that we can interact with on a day-to-day basis and learn what they're up to in their labs, and also great faculty where we can talk about teaching and learn how to best promote the spread of scientific understanding in the world. In a particular reason that I came to Iowa State is there's a really rich history in my particular field, which is atomic mass spectrometry. In the group of Velmer Fassel in the 1960s, and then carried into the group of Professor Sam Houck in the 1980s up to just a few years ago, atomic mass spectrometry was really invented here. From the inductively coupled plasma mass spectrometry was really invented here. From its roots as an optical spectrometry, source for optical spectrometry, until what we use it for, which is a source for mass spectrometry, was developed here and at Ames Labs. And so it's really, I'm really proud to carry on the torch, so to speak, and to develop new methods in ICP-MS and to keep Iowa State at the forefront of this measurement technology.